On today's episode, SpaceX catches a booster on landing. Would this work for airplanes? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. The most recent test flight of the SpaceX Starship demonstrated a new and novel way to land the very large first stage for reuse: capture in mid-air onto retractable arms above the launch stand. SpaceX Falcon boosters use retractable landing legs to effect recovery, but return to the launch pad has obvious advantages as speedy recycling of the vehicle is important. It's also an interesting approach to airframe weight reduction. Landing legs and associated actuators are heavy, but just as importantly, the airframe structure at the landing leg attach points has to be designed to handle landing loads and support the weight of the vehicle after touchdown. Now, that strength carries a mass penalty, and it's effectively dead mass, not contributing to the performance of the vehicle. The grid fins at the top of the booster, however, are aerodynamically necessary, and they're designed to handle the considerable air loads on the vehicle, and that's strength and mass that must be engineered into the vehicle. Using them to support the booster on landing means a minimal additional weight penalty. It's a clever way to increase system performance, remove complexity, and add convenience in the recycling process. But ever wonder if this could be applied to aircraft? Well, like so many innovations in aerospace, it's been tried before, in this case by this airplane, the Ryan Vertijet. Designed in the mid-1950s when there was a fad for jet-powered vertical takeoff, the X-13 Vertijet was designed around a similar premise to the Super Heavy booster. Eliminate the weight and complexity of landing gear by hanging the aircraft vertically, in this case from a cable. For a fighter jet, the advantages would be obvious. The aircraft could be trucked from site to site and launched and landed from almost anywhere. Now, in the days before sophisticated computer control, it did require a great deal of pilot skill, and critically, it meant that the thrust-to-weight ratio of the aircraft had to be above unity. It also required a reaction control system for flight control at zero airspeed. With jet engine technology of that time, this meant a very small and light airframe limiting useful payload. Well, it worked, but it simply didn't work well enough to be a practical proposition. And that's still true today, and modern VTOL military aircraft like the AV-8 and the naval versions of the F-35 use a rolling takeoff from carriers to gain some translational lift. Rockets, of course, don't use this strategy, but with the stated goal of SpaceX to recycle these vehicles and launch them like a scheduled airline, getting the Super Heavy booster back on the launch pad is a no-brainer. But from an engineering perspective, that translational lift is pretty attractive. The Space Shuttle's winged vehicle is very useful for getting back from space, and early concepts of that system used a winged flyback booster, a sort of giant shuttle strapped to the belly of the orbiter. Now, it was too expensive to develop, and I suspect that's the reason why SpaceX uses propulsive flyback technology today. Performance-wise, it would be useful if all the fuel could be used for orbital lift, rather than holding some back for landing, but the beauty of rocketry is that it's easily scalable. If you need to hold back 20% of propellant mass, make the vehicle 20% bigger. Now, we're a long way from booking suborbital rides to Europe in half an hour, and I'm not sure that propulsive landings are the solution to that problem, but the Ryan Vertijet in the 1950s and SpaceX Super Heavy boosters today, well, they're an interesting step forward. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.